Hey, welcome back. Let's talk about artificial intelligence today. Now, this is a topic that can feel a bit weird because some people have some, bad thoughts when they're thinking about self-thinking machines. And of course, there's lots of fiction existing where the machines take over the world. And I would like to shed some light onto this and explain what the basics, the underlying fundamentals of artificial intelligence is. And basically, it's a question of what kind of problem do you want to solve when you are involving artificial intelligence in some way, shape, or form. And there's basically two main distinctions that you can make. Whether you train the artificial intelligence, which is basically just an algorithm, meaning a set of rules, a set of mathematical rules that are to be applied, and whether you've got some training data for the stuff that you want to do with the artificial intelligence, or you don't. And that's how we determine whether we need some supervised learning algorithms, meaning you tell the system, okay, this is what I want you to do. These are some examples of stuff that I want you to differentiate. For example, emails that are spam versus emails that are not spam. This is a specific kind of algorithm called a classification algorithm. So you train that algorithm by telling them, okay, this is spam, this is spam, this is a spam email. And the more you train the system, the better it will be to classify an incoming email and to be able to determine whether, well, that's supposed to be a spam email or not. Now, it's important that you are able to undo sort of the result of the algorithm there. Because as you probably know, there can be some false negatives, meaning the system shows you an email that it thinks is not spam, but is actually spam and you want to have it removed. But that's probably not the worst case. The worst case is where the system doesn't show you an incoming email. It's a false positive because it thinks it is a spam, but it actually is not. And you would be expecting to see that specific message. Okay, so classification algorithms are some part of supervised learning artificial intelligence. And the idea is to get some incoming data and to be able to find the classes, meaning what kind of thing, what kind of email is this spam or not? What kind of thing is this incoming program there? Is it a spam or is it a virus, a malware or not? When you're thinking about credit card payments, credit card fraud detection, it's also some kind of classification there. But that's something different to the unsupervised learning examples that we have in the artificial intelligence. And there we're talking about clustering. Clustering means we let the system find by itself data items that are similar to each other. Then we don't really know how many clusters there will be, how many groups of similar items it will find. But it's basically up to the system, to the algorithm itself, to the mathematical rules, which is basically what all this artificial intelligence is. There's another name for it, by the way. It's abbreviated with ML, machine learning, which is maybe even scarier or not, depending on your train of thoughts there. But the idea is that, well, you provide some rules for the system to learn something, to deduce something. And with these clustering algorithms, it's able to determine how many groups there are, how many similar groups of similar items there are. And then to do its thing and to identify fake news, or also spam filters could be programmed with clustering algorithms. And so this is unsupervised learning. We don't have a set of training data there available. We just let the system, based on the input data that we have, figure out how to group the different incoming pieces of data into how many groups and how they are related to each other. And an example would be when you are browsing on some e-commerce website, you usually get some recommendations for future purchases, because the system has determined, by basically watching people interacting with it, by watching people, well, not watching sounds kind of weird, but just taking the data that's already there in the database and see, well, okay, if somebody, I don't know, bought a synthesizer, then the chances of them buying a cable with it are pretty high, because from all the people buying synthesizers, 80% of them bought also a cable with it. And that's why it makes sense for the system, for the e-commerce website, when I'm looking at a synthesizer of some sort on this website, it shows me, well, customers who purchase this item have also interested in these cables there. So that's how these decisions are being made. It's clustering algorithms, it's finding recommendations. People who are similar to my shopping behavior have bought these items, and that's why it makes sense for the algorithm to show it to me as well. And the last kind of algorithm is, again, some supervised learning algorithm, and this is where we take some input data to predict numerical, mostly future data, like the stock market prices or weather conditions. These are called some regression algorithms. And also regression algorithms are part of the supervised learning algorithms, meaning we have some training data. We know basically the current conditions of the weather or the past, 10 years of some stock price or some indices, maybe how they were behaving. And then we take this historical data to predict the future data. And this is what the regression algorithm does, basically. It takes the incoming data as training data and tries to fit a mathematical model there to be able to predict how this value, the temperature or the stock market price or whatever it is, will be behaving in the future. Okay, so this is what it is. Artificial intelligence, not that intelligence, it's basically mathematical rules that can be quite intricate and complicated, but in the underlying idea is always we want to classify stuff, we want to cluster similar items, and we want to predict a numerical value based on some historical value. And of course, there's lots of more details that you can learn about that. And if you sort of go into certain depth, then the mathematical basics will be necessary there, or even more than the basics. But maybe it's enough for you to know these kind of things, that there are stuff that you train, like trained supervised learning algorithms and unsupervised learning algorithms. And maybe if you interact with your day-to-day programs, with your favorite mobile apps, and you get some recommendations, or you get some classification of maybe an incoming email, you can think about, well, okay, this is the artificial intelligence working for me.